So in this video, we're going to look at multiplying radicals. So first of all, if this video helps, be sure to like, subscribe. You can leave a comment, whatever you need to do. All right, so multiplying radicals is actually a lot simpler than it would sound. So let's look at a few easy examples, and then we'll look at some complex examples. So first of all, let's say we have the square root of 2 times the square root of 3. Okay, now multiplying radicals, the way I remember it is basically you're multiplying the 2 and the 3, the two numbers inside of the radical, just like normal. Okay, so obviously 2 times 3 is 6. But since it's inside of a radical, the answer stays inside of a radical. Okay, and it's that simple. All right, like let's look at another example. Let's say we have the square root of 2 times the square root of 5. Okay, once again, we're going to multiply what's underneath the square root, which is 2 times 5, which is 10, but we're going to keep our answer under a square root. We could do the same thing with a cube root. Like, let's say we had the cube root of 2 times the cube root of 3. Just like the first example, except now we have a cube root. Once again, we're still going to multiply 2 times 3 to give me 6, but then we're going to keep everything under a cube root. And the same thing applies for a fourth root, fifth root, however far you want to go. All right, so that's as simple as I can make it as far as the overall concept. Now, most of the time, as you progress through math, you're going to get more and more complicated types of problems. Like, let's say we have the square root of 27 times the square root of 5. All right, now, what I would recommend you do is multiply no matter what once you begin. So let's multiply 27 times 5 and keep that under a square root. So that's going to give me the square root of 135. Now, this is where instead of our answer just being finished here, we could actually keep going and breaking down this radical. So what we're really doing here is combining what we've done in the past with breaking down a radical and then multiplying, which I may have already said this, but if I haven't, I've already done videos on simplifying radicals, so if you want to go check those out, I would, because I'm going to go through some of these pretty quick. All right, so once again, we're just combining the multiplication with the breaking down, so let's do the breaking down part now. So let's look for two numbers that multiply to give us 135, and we want one of those numbers to be the biggest perfect square that divides 135, and that would actually be 9. It would be 9 and 15. Because we can take the square root of 9 out, and that would give me 3. And then the square root of 15 can't be broken down any further. There's not a perfect square that divides 15 other than 1. So there's our answer. All right, let's look at another one. Let's say we have, we'll actually make this a little bit more difficult. Let's say we have 3 radical 10 times negative 2 radical 18. Now, what we haven't discussed yet is what if there's a number on the outside of your square root? Well, the good thing is we treat 3 and negative 2 just like coefficients. So we're going to multiply the 3 and negative 2, but it's going to stay on the outside. So the way I remember it is if it's already on the outside, leave it on the outside. All right? And then if it's underneath the square root, leave it underneath the square root when you multiply. So when we do 10 times 18, we're going to get 180, but we're going to keep that part under our square root. And now is once again where we have to try to break down this radical. Now, if you're on like a multiple choice test and you get to answer the question as a decimal or something, then you may not need to do this part. All right, but I'm going to do it because most of the time, most of the classes you're in are going to make you break this down. So let's see, what two numbers could we use here to break down 180? We could use 36 and we could use 5, because 36 divides 180 and it's the biggest perfect square that divides 180. So then that allows us to take out a 6 and leave 5 inside the square root. Then we have this negative 6 already on the outside, and that's going to get multiplied by our 6 that's on the outside. So our answer would be negative 36 radical 5. All right, now let's go a little bit further with this, and let's look at problems that have variables. Okay, now I've done a video previously about simplifying radicals when you have variables, so I would be sure to go check that out because I'm going to go through this part, well, the breaking down part, quicker than I normally would. But once again, it's because I already have a video on this. So be sure to go check that out. So now we're going to multiply these two radicals. And here's something that is just good to know. When you just have a square root and we have this 5 that we're trying to figure out, what do we multiply that 5 by? Well, there's an understood 1 to be in front of this square root. So it would be 1 times 5. So this 5 is just going to stay on the outside of our square root. So now we're going to multiply what's in the square root and leave it under this square root. So 6 times 8 is 48. Now, when we multiply x to the 4th times x to the 5th, we have to remember our exponent rules. And I've also made a video on this. So if you want to go back and review that, I would. But just briefly, when you multiply exponents, you actually add the exponents. So this is going to give us x to the 9th. All right, so now our job is once again to try to break down the square root. And you'll notice there's a variable with an exponent under that square root, which is more advanced, but we're going to go through it. So 5 times, let's first just start with breaking down the square root of 48. All right, let's not worry about x to the 9th. We'll do it over here in a second. So the square root of 48, let's see, the biggest perfect square that divides 48, you may think it's 6 and 8, but 6 and 8, neither one of those are perfect squares. So it's actually 16 and 3. All right, so now let's just break this one down. So we have 5 on the outside. Square root of 16 is 4, radical 3. All right, so now let's take care of this square root x to the 9th. All right, so once again, I've covered this in a previous video, but real quick, when you have a square root, you act like the index is 2 because the index is understood to be 2, which means you're going to take this exponent and divide it by 2. But you want the exponent to be divisible by 2, and 9 is not. So you're going to break this apart and say this is x to the 8th times x to the 1st, just like we did with 16 and 3. Once again, I'm going to continue just to make this video shorter because I've already done a video over this. So let's keep going. So now I can take x to the 8th and do the square root of that. I can divide this 8 by 2, and it gives me x to the 4th on the outside of my radical. But on the inside of my square root, I still have an x. So now when we put all this together, here's our final answer. We're going to take 5 times 4, which is 20. And then we're going to do x to the 4th. That's going to stay on the outside. And then on the inside, we have 3, and we have x. So this is our answer. Now, once again, I know that this is probably a more advanced problem, but give it a shot, see what you think. Obviously, some of these problems you may not see in the future, but you could. It's always better to be prepared rather than not. So let's do this. How about I do one more that's a square root, and then that'll be it. Well, one more with the variable, my bad. Let's do, if I can find one. Let's see. Yeah, let's do this one. All right, so let's try one more with a variable. And I would give this one a shot, because if you can do this one, you're pretty good with most of these problems. So 18w to the 7th times 10, well, 3 times 18, or well, the square root of 18w to the 7th. I think we can all read, so it's okay. 10 square root 4w to the 9th. All right, so give this one a shot. You could pause the video and do that. All right, so now let's go through this. So first of all, the 3 and the 10 are going to multiply to make 30. So now let's multiply what's under the square root and leave it under the square root. So that's going to give us, let's see, 18 times 4 is 72. W to the 7th times W to the 9th. Once again, we're going to add those exponents. So it gives us W to the 16th. All right, so this one's going to work out nicer for us than the last one. So once again, the easiest way to do this, I think, is to start with the number. So let's take 30, and then let's break down the square root of 72. All right, so the square root of 72, the easiest way to break it down would be using 36 and 2. So now we have 30. Let's see, the square root of 36 is 6. So 30 times 6, square root 2. And then we could even go further and break this down fully if we want. That's 180 square root 2. All right, so now do not forget that we still need to break down the square root of W to the 16th. Now, once again, the easiest way to do this is, remember, a square root has an index of 2. And when you have an exponent, if you want to do the square root of that exponent, w to the 16th, so the variable with the exponent. If you want to do the square root, you just divide your number by 2. And 16 is divisible by 2, so that's going to give us w to the 8th. So then we're going to put that in our answer, but notice it's not under a square root. So then here's our final answer. 180 w to the 8th square root 2. And we are finished. So once again, this is just a quick breakdown of multiplying radicals. Feel free to reach out, comment if you have any questions, and I can try to help. But that will be it for this video.